So building off of what we did on the previous page, we need to rotate x squared over 4 plus y squared over 1 equals 1 by 45 degrees. So, and then, write the equation of the new ellipse in general form. Tall order, that last part, but at least for the first part, we can, based off of prior investigations, I mean, there is a little shortcut approach that we can use to come up with the equation of the ellipse in parametric form. All right, and so if we rely on relationships that we've determined, over time, then things will start to get a little bit easier. All right, so what we're going to do first is rewrite this, because this is pretty uggo. So I'm going to write it as x over 2 squared plus y over 1 squared is equal to 1. All right. Now again, if you like the shortcut rules we determined in a previous, I forget what page it was, but previous page, then by all means use that. But I'm going to just kind of take it from scratch here. All right. We know that there's a relationship. All right. This is the Pythagorean identity. And that's cosine squared theta plus sine squared theta is equal to 1. All right. So if cosine of theta is equal to x over 2 and sine of theta is equal to y over 1, then we'd be able to make that substitution and our rule would apply. All right. So we're good there. So now I have a relationship that gives us x in terms of theta, so 2 cosine theta, and y would just be equal to plain old sine of theta. Now, if you're unsure, you know how to graph an ellipse in rectangular form, you can put your Desmos calculator in polar form and just graph. Parametrics are a little trickier, but you would just type it in as an ordered pair, the x comma y. So we kind of have to think of it that way anyway. For the theta, just type in theta, and it'll recognize it as the variable theta. All right, and then sine of theta. Okay, well, that didn't work. Okay, I must be misremembering. More on that later. I'll figure that out. All right. I could also be thinking of GeoGebra, so that could be a problem. Well, anyway, that's besides the point. So we now know that x is equivalent to 2 cosine theta and y is equal to the sine of theta. So if I want to rotate this by 45 degrees, that's telling me that based off of the model that we developed on the previous page, that phi is going to be equal to 45 degrees. All right. So that makes my rotation matrix, instead of cosine phi, negative sine of phi, and all that jazz, it's cosine of 45, which is radical 2 over 2, negative sine of 45, which is negative radical 2 over 2, sine and cosine of 45, each of which are radical 2 over 2. And we're multiplying this by 2 cosine theta sine theta. All right, so we carry out our matrix multiplication. Again, we're multiplying this by this, and then this by this to get our ordered pairs, or x comma y, and that would give us the parametric form of our new ellipse. And I'll have to figure out the whole Desmos thing, because it would be nice to be able to check that. All right. Anyway, so 2 cosine of theta multiplied by radical 2 over 2 is going to be radical 2, because the 2's will cancel, cosine of theta, plus a negative, so minus radical 2 over 2 sine of theta. And then, so that would be the new x value. We'll call that x prime. And then 2 cosine of theta multiplied by radical 2 over 2. So radical 2 cosine of theta plus radical 2 over 2 sine of theta. I just had a moment of inspiration, but I don't think it's going to pan out. Just do t's. Oh, it's going to pan out. Yeah, so I was using, well, first off, it was in polar form. It didn't need to be in polar form because it's parametric. So brain cramp there. And then typically when we use parametrics, we use t. That's what Desmos understands. And so I'm going to go from 0 to 2 pi. And there we go. All right. I get there eventually, folks. So that would be my y prime. So these are my two equations, my two parametrics that that would represent the rotated ellipse. All right. So I just want to verify that these are actually correct. All right. So I would write x prime equals and y prime equals. Copy paste being, of course, the best friend. All right. So to verify that this is correct, I'm just going to pop this bad boy right in and take a quick look. All right, so we're looking at, a little bit more typing. Radical 2 cosine of t, close it up, minus fraction tool, radical 2 over 2 sine of t, close it up, comma, radical 2 cosine of t plus fraction tool, radical 2 over 2 sine of t, close it up. Defaults to 0 to 1. I'm going to make it 0 to 2 pi. And it does appear to be a 45-degree rotated form of the original ellipse. All right, so very comfortable that that's a correct response. All right. So we're looking at the same figure, just a rotated form. All right. So the next one is pretty much the same idea. So as long as you have your transformation matrix, everything kind of works out. All right. So we now know that, or at least now we're going to rely upon the idea that with an ellipse, it's the square root acting as the coefficient. So 3 cosine of theta sine of theta we're looking at cosine of phi, negative sine of phi. And so with the phi being whatever the angle of rotation is. Cosine of 30 degrees is radical 3 over 2. Sine of 30 is 1/2, but negated. And so we're looking for 1/2 radical 3 over 2. And so you can kind of jump right to it. X prime, y prime. We're looking at 3 radical 3 over 2 cosine of theta minus 1/2 sine of theta, 3/2 cosine of theta plus radical 3/2 sine of theta. All right, so it's really just carrying out the matrix multiplication. As long as you could write your ellipse in parametric form, you're going to be in good shape, because again, this is my x and this is my y. All right, yeah, does it get a little bit more complicated? Sure. Looking at the next one, we have the same rotation matrix. So I can just hang on to that, copy paste. But in terms of the coefficients, not as lovely to look at. But I could say radical 40, but I'll write 2 radical 10 cosine of theta. I could say radical 45, but I'll say 3 radical 5 sine of theta. All right, so those are my x's and y's. So when I multiply to get my x prime, poor quality looking prime, so I'm just going to clean that up. We're looking at radical 20 cosine of theta, so that's going to be 2 radical 5 cosine of theta. And then nothing cancels in the next one, so that would be negative 3 radical 10 over 2 sine of theta. Y prime would be equal to, cancellation, radical 20, so 2 radical 5 again, because 5 times 4 is 20, you know, radical 4 is 2. Cosine of theta plus, and then we're looking at 3 radical 10 over 2. And same value, just different sign. All right, and then the last one, we're looking at 3 cosine of theta, 5 sine of theta. Again, the relationship that we discovered, cosine, negative sine. Cosine of 60 is 1/2. Negative sine of 60 would be radical 3 over 2. Then radical 3 over 2 and 1/2. And then it's just a matter of carrying out the multiplication. So here's my x, here's my y. X prime, y prime. And it's just the matrix multiplication. So 3 cosine of theta times 1/2, so 3/2 cosine theta. 5 sine theta multiplied by negative radical 3 over 2, so negative 5 radical 3 over 2 sine of theta. Then we're looking at 3 radical 3 over 2 cosine of theta. And then a positive 5/2 sine of theta. And all of this could be checked in Desmos, but you know, once you get an understanding of the different techniques, and things get a lot easier. All right. I'm going to save the next 2 little bits there for the next video, because they're not really related to what we were just doing. I mean, they're loosely related. It's just not directly related. So we have to do a little bit of